is my VMware vSphere lab. And today we're going to be decommissioning half of it. Why? We're about to embark on a migration journey to XCP-ng. Today I'm deploying the brand new XCP-ng 8.3 version. I'd love for you to follow along in your own labs, as I believe this is the best way to learn applied knowledge. So let's apply it. Also, there will be a full video index in the video description below. All right, enough. Let's get techie already. The two hosts that we shut down previously were extremely old Dell R620 servers. I'm replacing these with two Cisco UCS blades. I've already downloaded the XCP-ng 8.3 ISO. Let's get this mounted to our first host. I'll launch a console window via UCS Manager, enable the virtual media, mount the ISO, and then power on the host. First up, key map. We'll accept QWERTY US. A very nice warning message here that all data will be erased on this server. We also have the option to load device drivers. We'll just go ahead and click OK. You guys know what to do here, accept the end user license agreement. And notice here about BIOS mode versus UEFI. The recommendation is UEFI, so we'll click OK. Here I have my local disk. And I should say disks because they are in RAID 1. Later, we will set up NFS to a NetApp system. But for now, we'll click OK and just accept the default. For virtual machine storage type, I'm opting for ext file-based thin provisioning. And we're also going to use NFS for our VM storage later on. If you want more info on file type, I'll leave a link in the video description below. I'm using local media for the installation media. Okay, cool. I'll verify my installation source and we'll speed this up. No errors found. Great. Let's continue. Entering my super secure password. Here, I'm going to select my first network card. This will be used for management. For networking, we're using IPv4 only. We'll most definitely set a static IP. I'm going to use 192.168.1.26 along with my subnet mask and default gateway. Within my network, I use VLAN 1 for management. And this is tagged, therefore I need to use VLAN and enter in 1 right here. This host name will be XCP host 1, and I'll fill in my DNS servers addresses. Time zone will be Sydney, Australia. I'll provide manual NTP servers from ntppool.org. Here I've listed 3 servers to use. Let's kick this install off on our first XCP-ng host. Okay, and let's accelerate this. There we have it. Our first XCP-ng host installed. When I click OK, the host will reboot. Now tell me this doesn't look like ESXi. I'm in familiar territory and it's making this experience very familiar. Let's now take a look at each menu. Status display gives us some basic info. For example, the server, NIC, and management IPs. Moving on down to network and management interface. Pressing enter, we can access additional menus where we can make changes to our host networking. And those changes can be management, DNS, and NTP. However, we can also perform a test on our network, such as ping tests on some predefined or custom addresses. Pinging the default gateway is successful. Woohoo! Back on networking menu, we can view our network cards along with their MAC addresses. And lastly, for this section, if we need to hit the emergency red button, we can perform a full network reset. Take note here that all running VMs will be forcefully shut down and the host will reboot. Back on the main menu, let's take a look at authentication. Here we can authenticate to the host so that we can make changes. We can also change the root password and change auto logout time. This next option I think is fantastic. Virtual machines. Within this menu, we can stop, start, and migrate virtual machines. In addition, we can view host performance and display detailed VM information. Disks and storage repositories, another great option within this GUI. We can create storage repositories, local and remote within this menu. The first option lists current storage repositories. Second option allows us to create an NFS, iSCSI, or local repository. And the third menu allows us to attach an existing repository. This can be NFS, iSCSI, local disk, CIFS, or an NFS ISO library, which we'll take a look at later on. We can specify a storage repository for VM suspend images. And final option, specify a storage repository for crash dumps. By default, it is the local storage repository. Let's go back to the main menu and select resource pool configuration. This is equivalent to a vSphere cluster. Here, we can join an existing resource pool, remove this host from the pool, or designate it as the pool master or primary cluster node. Next up, we have hardware and BIOS information. This displays information about the system processor, system memory, local storage controllers, BIOS versions, and lastly, BMC version, keyboard and time zone. This is pretty straightforward and self-explanatory. Next, remote service configuration allows us to enable remote syslog logging and enable or disable SSH to the host. Technical support menu is really helpful. We can perform a basic configuration check on the server in which it checks three main components. Is virtualization enabled in the BIOS? VT. Is the local default storage repository okay? And lastly, is the management network interface okay? We can upload a bug report directly to Vates support FTP server. And this is what I love about this product. They just make everything so easy and simple. I can save a bug report to some removable media. And lastly, we are presented with the host XCP-ng version. We can enter or exit maintenance mode and reboot or shut down the host from this menu. Very last menu on this list, local command shell. Selecting this will drop you directly into the host's CLI. We're going to log out of this host GUI menu by going back to the authentication menu and selecting login/out. Now it's time to have some fun. Let's open up Chrome and browse HTTPS to our host's IP. Log in with the password we set during installation. This first screen displays some info about the host, such as CPU, RAM, storage, and network. The other tabs that we have access to at this stage are tasks and VMs. Before we do anything, we're going to deploy XCP-ng Orchestrator appliance, which is the equivalent to VMware vCenter. Open up your browser and head to https://vates.tech/deploy. Now, nice warning message highlighting that everything happening here on in is purely between your browser and the host only. Here we'll enter in our XCP-ng host IP along with the root username and password. I'll select local storage for the XOA deployment. And don't worry, we can move this later on to our NFS data store for better availability, performance, and resiliency. For networking, I'm going to select pool-wide ETH0 on VLAN 1. Untick DHCP, and let's type in our IP address of 192.168.1.25. Netmask of 255.255.255.0. DNS 192.168.1.101, and lastly, gateway 192.168.1.1. And I'm going to add one more DNS, which is going to be 192.168.1.102. I'll use sysadmin at vmlab.local for my login, along with a secure password. And for XOA SSH, I'm going to change the user to sysadmin-SSH and enter in a password. Hit deploy and sit back and watch the magic happen. FYI, it does take about 10 to 15 minutes to finish deploying. Therefore, we'll speed this up. Now that XOA is deployed, let's log in. Username sysadmin at vmlab.local and my password. Before we connect our host into XOA, let's create a Vates account by clicking the hyperlink above. Enter in an email, then click free sign up. This will give you 30 days trial access to the full version of XOA. After that, you can decide to purchase a license, or if you ask nicely, Vates can extend your trial a little longer. You will then get an activation email, click on the link to register. Once done, return to XOA. Back in XOA, click on the XOA menu on the left, and in the registration block, enter in your email and password that you used to register on the Vates website. We are now registered and have a trial for 30 days. Next, we're going to upgrade our XOA appliance. And on the same screen, click on the upgrade button. This will take a few minutes, and during the upgrade, you will get disconnected from XOA. Wait a few minutes and then refresh the page. We need to perform the upgrade once more to upgrade packages. Click that green upgrade button again. Same process, we'll get disconnected while upgrades are happening. wait a few minutes, and then refresh the page. Updates are now complete. That's cool. Notice on the left side, we now see Premium. It's worth mentioning this actually gives you access to Vates support during your trial. Any issues you run into, feel free to log a support ticket. You can do that by clicking on XOA, selecting support, and then clicking on create a support ticket. Let's take a look into our host. Click on Home at the top left and select Hosts. I'll click on XCP Host 1. The General tab shows us some simple utilization graphs, such as CPU, RAM, network, and storage. This Stats tab gives us a little more detail into the host utilization. Console tab allows us to console onto the host. Network tab displays our host's networking. I'm going to create 2 network bonds. A bond meaning a combination of network interfaces to act as one. To create a bond, we're going to go to the home menu and select pools. I'll click on XCP Host 1. And before we go any further, I'm going to change the name of my pool to XCP Pool 1. You'll notice underneath I can also edit and type something like location or any other info that you like. A pool is like a cluster in vSphere terms. This General tab shows us some basic pool usage stats. The Stats tab shows us performance stats in the form of graphs, and you can change the time frame right here. However, it's network that we need right now. You'll notice this mimics the same NIC layout as my host, along with VLAN 1. I'm going to click on Add a Network. Enable Bonded Network. For my first bond, which by default will be called Bond 0, I'm adding in ETH0 and ETH1. I'll call my bond Data. You can give it a description as well. I'll keep this bond MTU as 1500, and for bond mode, you can see that there are 3 options. Balance SLB, which will use both NICs and balance traffic across them. This doesn't rely on any port channel setup on your switches. Active Backup will use one NIC as active. If that NIC goes down, we'll fail over to the other NIC. LACP will require an LACP port channel config on your switches. For UCS, we can't configure LACP. Therefore, I'm going to use Balance SLB. When I click Create, it will not only create Bond 0, but it will also move my management IP along with VLAN 1. Notice in the list that we see Data bonded. Then on the right, we see Bond 0 with no VLAN. This is like the parent bond. Then if we scroll down a little bit, we'll see Bond 0 with VLAN 1. This is where my management IP is currently residing. Next, we'll create a storage bond. Click on Add a Network. Turn on Bonded Network, and I'll select ETH2 and ETH3 for this bond. Give the bond a name and a description. This time, I'm going to use MTU 9000, as this bond will be used to connect to my NetApp NFS storage, which uses jumbo frames. Bond mode will be the same as our first one, Balance SLB. Right, we've created the bond. Now we need to create the VLAN interface. Click on Add a Network again. This time for interface, we're going to select our storage bond called Bond 1. Give the VLAN interface a name and description. We'll set MTU 9000, VLAN 8, which is my NFS storage network, and lastly, I'll set NBD as no NBD connection. NBD stands for Network Block Device and is used to speed up backups. It works between XOA and XCP-ng VMs. Click Create Network. Before we leave this tab, I'm going to change the name of VLAN 1. To do that, I'll click here and type in Management. You probably noticed that there's no place to set an IP here. And you're right. To do that, we need to head back to Home, Hosts, and click on our host, then Network tab. Within the column mode, for row Bond 1 NFS, I'm going to select Static. I'll enter in my IP for this network, which is 192.168.8.25, subnet mask 255.255.255.0. The rest we can just leave empty. Let's verify we can communicate with our storage IPs and test jumbo frames. I'll click on console and ping the NFS storage with this exact command. -m do means it will not defragment the packet, and -s is ping with 8,000 byte packet size. Let's go. Excellent. We have verified connectivity. Now we can mount our NFS storage. Click on Storage tab. Click on Add a Storage button, type a name for this storage resource and give a description. Select NFS storage type. For server, I'll enter in my NFS server IP and click on the magnifying glass. NFS version, I'll leave default. And for NFS options, I'm going to type hard for hard mount. A hard mount means that if the NFS server is unresponsive, the client will continue to retry indefinitely until the server responds. Hard mounts also help prevent data loss by ensuring that read-write operations eventually succeed. I'll select my path and then click on Create. And voila, we have our first NFS storage mounted. Now let's go back and click on Home and VMs. Here we have our XOA server running all by itself, but it is still running on the local disk on XCP host 1. We're going to fix this right now and move it to our NFS storage. Why is this important? Because we're also going to introduce a second host to our pool, and if the XOA VM is on a local disk on host 1, then host 2 won't be able to see it. Therefore, we use shared storage. Click on the XOA VM. Then click on the disk menu, select the disk and click on the arrow pointing to the right, which stands for Migrate. I'll use the drop-down menu to select my new NFS data store and click OK. The migration process has kicked off. After a few minutes, the VM will have successfully relocated. If I click on XCP MGMT Platinum 1, I can see we're now consuming 2.7 GB. On the stats page, we can see live performance stats. Not really much going on at the moment. The disk tab shows us the VM's disks. Host tab shows us which hosts have this storage mounted. Logs are simply logs. And lastly, advanced. We can reclaim freed space, which is only used on block storage such as iSCSI and Fiber Channel. We can place this storage resource into maintenance mode, which prevents any new writes to the disk. And we can remove this storage resource. Let's move on to adding our second XCP-ng host. Before doing this, there are some prereqs. Number 1, the host must be the same XCP-ng version. Number 2, networking must be similar and have access to the same VLANs as host 1. And number 3, must have access to the shared storage, in our case, NFS. Let's connect to host 2. Select resource pool configuration and join a resource pool. Log in with your root account. The pool master is host 1. Therefore, I'm going to type in the IP address 192.168.1.26 along with the root username and password. Press enter, followed by F8 to join. Operation was successful. Press enter. Let's switch back to XOA. Click on Home, Hosts. Host 2 is there, which is great. Click on Host 2 and go to Network tab. All of our bonds and VLANs we created previously are automatically applied. It's just so convenient. You probably noticed that NFS is disconnected, which is okay because all we need to do is add our static IP. Remember how to do this? Under Mode menu, select Static, enter in the NFS network IP and subnet mask. Click on the disconnected button for the interface and click OK to connect the PIF. PIF stands for Physical Interface. Head on over to the Storage tab and click on the disconnected button to connect the NFS storage. Perfect. We now have the ability to move the XOA VM amongst hosts. And we want this ability because we're about to patch our hosts. Yes, that red circle you've been seeing above the Patches tab this whole time is about to be rectified. But we're not going to simply click on Install all patches on the host. No. We're going to use our pool. Therefore, let's head on over there. Click on the Patches tab. We have 2 options to install updates: Rolling Pool Update and Install Pool Patches. Rolling Pool Update is an automated feature rolling through each host one by one. Firstly, it evacuates any running VMs, applies the update, and then reboots the host. Install Pool Patches is more of a manual process. It will install the patches to all the hosts, but then we'll need manual intervention to migrate running VMs and reboot hosts. We'll keep things simple and use the Rolling Pool Update. A nice warning message here. Thank you. And that's it. Process has started. You can see in the host that host 1 has turned from green to gray, meaning it is disabled. XOA has been migrated to host 2. What you will notice here is that XOA will lose connection to the host because the pool master has been rebooted. This is normal and there is no automated failover by default of the pool master. Once the pool master is back online, you will be able to see all your hosts again. Now we can see host 1 has turned green and host 2 has gone gray, meaning that it is now disabled, preparing to install updates, followed by that reboot. Because our pool master is now online, we won't be disconnected from XOA. Once host 2 is rebooted, you can see that it is removed from the hosts list. This is normal behavior, so don't freak out. While we wait for host 2, you're probably wondering what happens if the master is lost permanently. Well, all the remaining hosts are acting as slaves, and either one of them can be promoted to become a master. This is done via the CLI using the following command. Yeah, I'm not going to say that, just you can read that text up on screen. To get the host UUID, you can use this CLI command, xe host-list. Host 2 is back online, but we can still see one warning. No need to worry about this, as it's just highlighting that we don't have pro support enabled as we are in trial. Our next step in our setup journey is to enable high availability. In the event of a host failure, the VMs running on the affected host are automatically restarted on another available host in the pool. A few prereqs are needed here. Number 1, shared storage, which we have with our NFS storage repositories. Number 2, similar hardware, including CPU types. And number 3, NTP sync amongst all hosts. To enable HA, we navigate into the pool by hovering over Home and then selecting Pools. Click into the pool and select Advanced tab. Next to high availability, enable the toggle switch. A window pops up asking us to select the heartbeat storage. Here I'll select my NFS MGMT Platinum 1 storage and click on OK. HA is now enabled on the pool. A quick side note here, the heartbeat SR is used to store metadata that the pool uses to determine the state of the hosts. Therefore, it's important that the underlying storage is redundant and highly available, which it is in my underlying NetApp. Now that HA is enabled on the pool, we can enable or disable this per VM. To do this, we go back to Home, click on VMs, and click into the VM. Click on the Advanced tab and scroll down to HA. Here we have 3 options: Disabled, Restart, and Best Effort. I will select Restart, meaning it will reserve resources and always restart on another host. Best Effort means it will restart on another host only if the resources are available. Best Effort does not reserve capacity in advance and is generally used for non-critical workloads. Next, we need a data store to hold our ISO images. This will be another NFS storage repository that will mount from our NetApp. I'll head over to Home and then Hosts. Select my host and click on the Storage tab. Click Add a Storage. Give the storage a name. I'll use XCP-ng _ISO_silver and also enter in a description. For select storage type, select NFS ISO. I'll enter in my NFS server IP, then click the magnifying glass on the right. Use the drop-down menu to select the path, leave NFS version as default, and for options, type in hard for hard mount. Once you're done, click on Create. To upload an ISO image, we'll use the menu on the far left and select Import Disk. Select our ISO storage, and then we can simply drag and drop an ISO image and click Import. I'll also add in a Microsoft Windows Server ISO. Let's rename the ISOs to something shorter. These ISOs will now be available to mount to VMs. It's now time to configure our XOA and Pool metadata backups. But before we do this, we need to configure some backup storage. This is known as File System Remote, or Remotes for short. Click on Settings, Remotes. Type will be NFS. Give the backup repository a name. Mine will be XCP-ng underscore backup underscore 1. Don't select any proxy. And because we're using a Synology for backups, I'll enter in its NFS IP address. Now, crucial point, don't keep your backups on the same storage as your production. Please don't do that. We'll leave port blank and then fill in the path to your NFS mount. Then for mount options, we'll type in hard for hard mount. If you want to encrypt your backup storage, enter in a 32 character key here. It's extremely important you don't forget this. Doing so, you will not be able to access your backup data. Therefore, keep this key safe. I won't be using encryption for this demo. Therefore, I'm going to leave this field blank. When you're ready, click Save Configuration. We now have our backup storage mounted. This means we can head on over to configure a backup job. On the left-hand side, hover over Backup and click on New. Select XO config and Pool metadata backup. Give the backup a name. Select both Pool metadata and XO config. Target remotes, select the NFS storage that we just mounted. I'm going to skip the settings section and simply select my pool at the top right side. I want to create a schedule that backs this up each day. I'll click on the plus symbol in the schedule section. Name this schedule daily 11 p.m. I'll change the retention to 5. Select every month, every day. For hour, select 23, and minute, we can leave on 0. Move the slider to 7 and click OK. You can notice that the schedule is disabled. If I click on it, it will turn to enabled. And finally, click on the create button at the bottom. Because we didn't specify a proxy here, it means that the XOA VM will try to mount the NFS backup storage directly. However, if we take a look, it doesn't have a NIC in the same subnet, and there is no routing to the NFS network. So let's fix this quickly. Click New Device, use the drop-down menu and select NFS. Click Create. The interface is added, and now we need to configure the IP. We can do this in the CLI. Click on the console tab. Log in with user XOA and the password you set during the XOA deployment. Type in IP link. You can notice that the second NIC is called ENX1. Notice that capital X as well. We need to edit the /etc/network/interfaces file. I'll use sudo nano. I'm going to copy what's in the file for the interface ENX0 and adjust it for ENX1. Once done, save the file and exit. Restart the network using sudo systemctl restart networking. Type IP ADDR to see the new IP. Try ping an IP on the NFS network. Make sure that it's replying OK. If we go back to settings, remotes, and click enabled under the state column, then click it again, we should be OK now. Go to backup overview and click play next to our backup job to trigger a manual backup. In just a few seconds, the backup job has completed and a log is displayed below. Now for the grand finale. Let's import some VMs from VMware vSphere. Within vCenter, we have 2 VMs to import into XCP-ng, an Ubuntu one and a Windows 2022 server. Both these servers are running web services, and if we browse to each of the server's IP using HTTP, we can see the simple text output. Before we run the import process, there is one thing we need to do, and that is remove VM tools from both servers. Within Ubuntu, we simply type sudo apt remove open VM tools. For Windows, we go into Programs and Features, select VMware Tools and click Uninstall. We also need to shut down both VMs. We can have the XCP import process do this for us, but we're here now, so I'll just shut them down. With my 2 VMs powered off, let's head back to XCP Web UI, hover over Import and select From VMware. Enter the vCenter IP along with the admin user credentials. I'm going to enable Skip SSL check and then click on Connect. I'll then select the VM. Make sure your pool is selected. Select the destination storage on XCP-ng. Select the network. In my case, it's the management network. As mentioned previously, you can have the import process stop the VM for you, but we've already done that, so nothing we need to change here. I'll leave stop on error enabled. Original template, I'm going to select Windows Server 2022. A template in XCP is equivalent to VMware's guest VM version. Everything here looks good to me. Therefore, I'm going to click on import and start the process. After the import completes, we are presented with our first imported VM window. Before we do anything, let's go back to the import window and let's import our Ubuntu server. Select my Ubuntu VM, followed by the pool, storage, network, and template. When you're ready, click import. Import is now complete, and we're presented with the VM screen. Let's power on the VM, and while it's powering on, we'll take a look through the menus. To power the VM on, we simply click the play button. Because we're running on a new hypervisor, we're going to need to install some guest utilities, which is equivalent to VM tools in vSphere, and we'll do this shortly. The general tabs show some quick stats of the VM, along with the ability to create tags and notes. An example of a tag would be environment equals production and criticality equals medium. I'll add a basic note to the VM as well. Clicking on the stats tab, we get a better overview into the performance of the VM. Though we must install guest tools before we can view the memory utilization. I can also use the drop-down menu to change the time frame. Click on the console tab, and here we'll install our guest utilities. But first, we'll need to set up our IP addressing, as the nickname changed during the migration. To do this, log in and type IPA. Here we can see our network card is called ETH0. Next, sudo nano/etc/netplan/00-installer-config.yaml. Within this file, I'm simply going to change my previous ENS 160 to ETH0. Once changed, Ctrl X to exit. Save the file by pressing Y, followed by Enter. Type sudo netplan generate to test the config. If you're getting the warning about permissions, you can simply fix that by typing sudo chmod 600 and the path to the YAML file. Also, if you're seeing the warning about gateway 4 has been deprecated, you can fix this by editing the YAML file and replacing gateway 4 with routes column to default via gateway IP address, like in my example on the screen. Save the file and exit. Sudo netplan generate. No issues or warnings now, then type sudo netplan apply. Type IPA, verify our nick is still good. Let's ping the famous 8.8.8.8 and let's make sure DNS resolution is working by pinging www.google.com.au. With Ubuntu, we are lucky because we can pull the guest utils from the apt repository. And this is done by typing sudo apt install xe-guest-utilities. Click back on the stats tab. And now we can see the graph for memory. Click on the network tab. Our IP address is now populated, connected, and everything is looking healthy. Click on the disk tab. Here we see our disk size and which storage repository it resides on. We can change the description of the disk to primary disk. Next up, we have the snapshot tab. We have two options here. First is to take a consistent snapshot by clicking on the New Snapshot with Memory button, or click on the New Snapshot button will simply create a crash consistent snapshot. Once the snapshot is taken, we can optionally change the name and the description. Click on the Backup tab. Currently, there are no listed backups. We will configure backups for these two VMs once we finish with our Windows VM. The Logs tab displays any events that have occurred on the VM. Here we can see the VM was started and a snapshot was taken. And finally, we come to the Advanced tab. The buttons at the top are pretty self-explanatory. However, I will call out a few. Coalesce leaf. You're probably thinking, what the hell is that? Well, this process is responsible for merging older snapshots into the base disk to make the entire chain more efficient. This merging helps in reclaiming unused space and reducing I/O overhead that can occur if too many layers are linked in the chain. Warm migration is used to migrate the VM between hosts. However, there is a small disruption. You would use this if live migrate isn't available. How big is the disruption, I can hear you asking? Well, let's test it. I'll run a constant ping to the VM and we'll trigger a warm migration. As you can see, this works by first copying the VM to the destination storage resource, shutting down the source VM, replicating the final changes, and then can optionally start the VM. Let's see how long this takes. I'll keep the source VM and click OK. I'll hover over the home menu and select VMs. I can see the VM is being migrated. During cutover, it only dropped 11 packets, which is pretty good. And you also have a clone of your VM. I'll delete the original source, and I'm going to change the name and description of this Ubuntu VM. Let's return back to the Advanced tab. Next, we can convert this VM to a template. And this template can be used to provision additional VMs in the future. It's worth noting here, you can only click this button once the VM is powered off. Next, we have boot order, and you can move these around with your mouse. I'm not going to go through all of these settings, though I'm going to highlight a few of them. First being CPU wait. The wait indicates the priority of the VM when it comes to accessing the physical CPU, especially under contention. The higher the CPU wait, the higher the priority the VM gets for accessing CPU resources compared to other VMs. CPU cap sets a hard limit on the maximum amount of CPU resources that a virtual machine can consume. It restricts the maximum CPU usage of a VM regardless of how much physical CPU capacity is available in the host. This works as a percentage. For example, if you set the CPU cap to 50%, the VM will only be able to utilize up to 50% of a single physical CPU core, regardless of how much additional capacity is available. I can protect this VM from being accidentally deleted or shut down. Unfortunately, the nested virtualization option is not available on this release. Therefore, you can't run additional hypervisors as VMs inside XCP-ng. I really hope that this comes soon, as it's essential for lab environments. I'll enable HA for this VM. If an XCP-ng host dies, this VM will automatically start on another host. Down on boot firmware, you have the option to use BIOS or UEFI. If you want to use secure boot, you must be using UEFI. Viridian refers to a set of paravirtualization PV features developed by Microsoft, commonly known as Hyper-V enlightenments. When enabled, these features allow Windows Guest VM to run more efficiently by improving its interaction with the hypervisor. Under VM limits, you can see we are using 2 vCPUs. In the topology option, we can drop this down and select to use 1 socket with 2 cores per socket, or 2 sockets with 1 core per socket. This is quite important if you have licensing requirements. And one that comes to mind would be Microsoft SQL. vUSB is also quite important, especially if your software requires a USB dongle for licensing. You can attach a physical USB to the server and pass this through the VM. Attached PCIs, PCI pass-through, allows you to assign a physical PCI device like a graphics card, network interface card, or HBA that is physically installed in the host server directly to the VM. Imagine dedicating a GPU to a VM running AI workloads, for example. This is all possible with attached PCIs. Under the miscellaneous section, resource set in XCP is a way to create logical groups of resources, such as hosts, VMs, storage, and networks, which can then be assigned to specific users or groups. Think multi-tenancy or department-specific access. ACLs in Xen Orchestrator are used to define permissions for users and groups regarding what actions they can perform on different resources. And last but not least, the VM Creator dropdown indicates the user account that was responsible for creating the VM. Scroll back up to the top, and here we have some quick access buttons. Stop and start the VM, reboot and live migrate the VM, take a snapshot. I can even export the VM as an XVA or OVA file. And last button is to make a copy of the VM. 2 options are available, full copy or fast clone. Remember, this Ubuntu VM is running a web server. Therefore, let's test that it's working. I'll close down my previous tabs, open up a new one, and browse http://192.168.1.64. And there it is, completely migrated from VMware and 100% in working order. Before we power on this Microsoft 2022 Server VM, I'm going to click on Advanced tab, scroll down to Secure Boot and disable it. Now let's start the VM. I'm going to click on the little keyboard icon, which sends Control-Alt-Delete to the console. Then I'll log in. As the network adapter has also changed within Windows, we need to re-enter our IP info. I'll do that quickly now. The warning message highlights that this IP is already taken by the VMware VxNet3 adapter. Click Yes will remove the IP from the previous adapter. We'll perform our ping tests on 8.8.8.8 and www.google.com.au. This all looks good to me. Next, we're going to be installing guest tools, but this time we're going to use the ones from zenserver.com/downloads. Why, you ask? It provides better support and performance. It gets regular updates and latest drivers. After downloading the package, run it and complete the installation using the default options. Once complete, give the VM a reboot. Click back on the General tab and you can see the management agent is detected along with the version number. I'll add in our tags and my VM notes. Back in the VM console, after logging in, we can see Xen Server VM tools installed successfully. Now I just checked and the NIC adapter changed again due to the install of guest tools. I'll quickly set up the IP information, default gateway and DNS here. Click on Yes to remove the IP from the previous adapter. Let's perform our ping test just once again, 8.8.8.8 and www.google.com.au. Everything is working fine, but one last test we need to do, and that is for our web server. Is it working? We shall find out. I'll open up a new tab and head to http://192.168.1.65. Voila, success. Now, if we go back in time, remember we configured our ISO storage and uploaded a Ubuntu and Windows 2022 server ISO to it. Well, that is now available by using the drop-down menu here. We can simply select an ISO and it will be mounted to the VM. We're almost at the end of this video, but there's one crucial task we still need to do, and that is set up our VM backups. On the left-hand side, hover over Backup and select New. I'm going to use VM Backup and Replication option. I'll give my backup a name, Daily VM Backups. Click on Delta Backup. This type of backup will create a full backup followed by incrementals. The full backup, along with all the incrementals, are referred to as a chain. Note that the full chain is required to restore a VM from a point in time. For the target remotes, I'll use the drop-down menu to select our backup repository. Click on Advanced Settings, go down to Concurrency, and here you can set the amount of concurrent VMs to be backed up in parallel. I'll enter in 2 here. For number of retries, if VM backup fails, I'll enter in 3. In full backup interval, I'll enter in 7 for 7 days. At the 7th day, a new full backup will be initiated and a new chain will form. Enable use NBD plus CBT to transfer disk if available. NBD is short for Network Block Device, and CBT is short for Change Block Tracking. Enable Purge Snapshot Data when using CBT, because we don't want to keep any snapshots that are created by backups. For the rest of the settings, we'll leave as default. Scroll to the top of the screen, and on the right side, we need to select our VMs. Turn on Smart Mode. I only want to back up VMs that are in a running state that reside on my XCP pool 1 and with a tag of env:production. Under Sample and Matching VMs, you'll be able to see the VMs that match our criteria. Click on the plus symbol next to the schedules. I'll name my schedule Daily Backup Schedule and set a backup retention of 7. I'll enable Health Check, which works by automatically performing a test restore, ensuring the VM boots up, and then removing the temp VM. We'll use one of our management data stores for the temporary restore. Make sure all months and days are selected. Then for hour, I'm selecting 22 and minute at 0. This will run the backup every day at 10 p.m. When you're ready, click on OK. Scroll all the way to the bottom and click on Create. As it's midnight here right now, we've missed the 10 p.m. window. I'm going to start the backup job manually. This will take a little while to complete, therefore we'll fast forward to completion. I left this overnight, but you can see in the backup job log that it took 14 minutes and transferred 30 GB. Backups are now sorted. But what if we need to restore a VM? Well, let's do that right now. Hover over Backup on the right menu and select Restore. Here we have 2 VMs. Have a look under Available Backups. We have 3 backup points available. Let's perform a restore of our Windows VM. First, I'm going to power off the original VM. Then return to the Restore window. On the far right-hand side, click on the second icon. I'm going to select the latest backup, followed by a destination storage resource. I will enable Generate a new MAC address and click on OK to start the restore process. Now don't worry, we won't be overriding our source VM. The restore process will create a new copy of the VM and append the date and the time to the VM name. The restore is now complete. Let's go to the VM list, and here is our restored VM. There is some descriptive text highlighting that this VM was restored on November the 28th, 2024 at 12:44, which is UTC time. We even have a restored from backup tag. All other tags are the same as the source, along with the VM notes. I'll power on this VM. Log in, and the first thing I want to check is if it maintained the IP addressing. And yes, it did. I'll test our website again, and website is working. I can even restore a file from backup by hovering over Backup and selecting File Restore. Select the VM, backup file, disk partition, and then browse through the folder structure, select the file or files along with the export format and click OK. Extract the files and then browse through until you reach your restored file. Before we wrap this up, I want to show you the pricing for XCP-ng. Head on over to this URL and take a look at the 4 options. For an enterprise, 4 hosts minimum at $1,800 USD per host per year. And this includes 1 hour support response on critical issues, full 24/7 support, setup, upgrade assistance, and also includes Xen Orchestrator appliance. It's almost a no-brainer. Ladies and gentlemen, we have done it. Thank you for coming on this journey with me. Hope you had fun, and if there are any questions, please leave them in the comments below. Happy testing, deploying, migrating. Have a very Merry Christmas and a Happy New Year. See you all again in 2025. Bye for now.